Hello, welcome to a video lecture on how to describe matter. And before I go ahead to describe matter, let's talk about what matter is. So matter is anything that has weight or mass and has volume. So again, in this course, weight and mass, they're kind of the same thing. And volume is the amount of space that a material takes up. So for example, a glass is a matter because it takes up space, it has volume, and it also has weight or mass. Also, the air that we cannot see. The air is also matter because, again, it has weight and it also has volume. And the same thing for water, like liquids. They are also matter because they have weight and they also have volume. So that is matter. So what are some ways to describe them? Well, matter has different properties, physical properties and chemical properties. Therefore, we can describe matter using the physical properties or the chemical properties. And today we're going to talk about the physical property or properties. So first of all, what is physical property? Well, physical property is a characteristic of matter that can be observed or measured without changing its chemical identity. It can be quantitative or qualitative. So let me give you a little breakdown of what qualitative physical property actually means. So qualitative physical properties can be described and compared using words. Some examples are color, odor, texture, or and state. So for example, if I were to describe a matter such as strawberry to you, I can describe by using its color. For example, I would say, the major component is red, and also it has a green component at the top. I can also describe strawberry using the odor. I can say that strawberry has a kind of like a sour, sweet smell to it. And also I can describe the texture. It's a little bit soft. And also I can describe its state, because strawberry is a solid. I can say that it's a solid. So again, we can describe matter using qualitative physical properties, which are usually words. Also, we can describe matter using the quantitative physical properties. So quantitative physical property can be measured and assigned a numerical value. So for example, boiling point, melting point, mass, volume, and density. So for example, if I were to describe water, this pot of water here on the right-hand side, using quantitative physical properties, I would say that the water has a boiling point of 100 degrees Celsius, right? And I can also describe this water using the mass. Maybe this water weighs somewhere around, 20 grams. And then we can also describe water using the volume. So for example, this water has a volume of 1 liter. Okay. So mass and volume, they are very commonly seen as the quantitative physical properties. So again, all matter has two things in common, mass and volume. Mass is the quantity of matter in an object or sample. And we usually use kilogram, gram, milligram, pounds as units for mass. And volume is the amount of space that a material takes up. So the units usually would kind of varies depending on what kind of matter you're talking about. If it's like a solid matter, we will use cubic meters. If it's a gas or liquid, we'll usually use liters or milliliters. And density is also a physical property, a quantitative physical property related to mass and volume. So again, density is a quantity of mass in a certain volume of material. Units could be, again, depending on what kind of matter we're dealing with. If we're dealing with solid matter, it can be grams per cubic meter or cubic centimeter. We can also describe liquids and gases density, and we will use units such as grams per milliliter or grams per liter, for example. So how do we calculate density? How do we determine density mathematically? So determine density, we need to measure the mass and volume of that matter and then calculate using this equation. So we'll have basically mass divided by volume, then we'll get density. And in order to get mass, we can multiply density by the volume of that particular object. In the same scenario, if we were to get volume of object A, then we can use mass to divide by density, divide by the density of that object A. So just an example here. So if a sample of jet fuel has a mass of 0.3 gram and a volume of 10.3 milliliter, what is its density? So first step, we need to find out what the mass of that jet fuel is. So it will be 8.3 grams. And then the volume, which will be 10.3 milliliter. Then we simply plug it into the equation. We'll have 8.3 divided by 10.3, which will give us 0.806 grams per milliliters. Okay, so just a little fun fact for you. The density of water is about 1 gram per milliliter. So when you compare the density of these two matter, you will find out that water has a higher density. Therefore, when you combine these two things, in a cup, in a mug, you will find out that the jet fuel will be floating on the top of water because it has a smaller density. So another question here for you, just to test your understanding. So the grape and foam have the same mass but different volume. So they both have 6.74 gram as their mass. In that case, which substance do you think will have a greater density? And please explain why. So please pause this video until you have an answer. You can unpause this video. So if the mass stay the same, so they all have 6.74 grams as the mass. If we have, if the volume is bigger, let's say since the volume of the foam is bigger, it takes up more space. Therefore, the foam has a much smaller density. And this is because volume and density, based on the density equation, they are indirectly proportional to each other. So if the mass stays the same, if you increase the volume, you're going to decrease the density. So just to remind you here, density is not mass. So density is the amount of mass in an object per certain amount of volume. Mass is a measure of how much matter there is within an object, typically given in grams. So again, the relationship between density and mass would be mass of object A is equal to density of object A times volume of object A. So if we're comparing two items, if they have the same volume, the larger the mass, the larger the density will be. And if we, again, comparing two objects, if they have the same mass, going back to the grape and foam example, the bigger the volume, the smaller the density will be. So that's it for today's video lecture. Please answer the following two questions, which you can also find in your lecture note. The first one here will be describing an object with both quantitative and qualitative descriptions. So you can just find a random object in your room and try to describe it. And then next day when we come in, we'll ask you to share share that to your partner and see your teammate and see if they can figure it out. Also, you need to list the liquids in the order of most dense to least dense for the picture here. Okay, so based on this picture here, can you list the liquids in order of most dense to least dense? So that's it for today's video lecture. I will see you all next time. Bye.